Welcome to Security Weekly Unlocked and this sponsored demo by ExtraHop. I am your moderator, Matt Alderman, formerly the CEO at Security Weekly and now Executive Director at Cyber Risk Alliance. Joining me is Chris Abella from ExtraHop to discuss and demo cloud-native security and control for the hybrid enterprise. Welcome, Chris.
Thanks for having me.
Before we get into the demo, I want to talk a little bit about some of the challenges when it comes to hybridized environments. And when we think about organizations that are moving to the cloud, they're not 100% cloud. They're partially cloud, partially on-prem. And that creates some very interesting challenges when you think about monitoring network traffic.
Yeah, absolutely. I think one of the initial challenges for corporations is where they've actually started to put their critical assets. In my experience, many of my customers are cloud, not averse, but just starting to dip their toe into cloud. And so it's a slow process as they move more and more of their critical business applications into the cloud. And as you move those applications, your boundary is going to expand in terms of your security boundaries, where you actually care about having network monitoring. And as you move into the cloud, the entire point is abstraction, right? We're trying to abstract away from having to deal with speeds and feeds with the underlying architecture and infrastructure, which means we've kind of abstracted away from a core source of data being the network. And so we're really just starting to see cloud vendors in the last couple of years recognize the criticality of the network as a source of data and start implementing things like traffic mirroring, essentially what is an on-prem spam, but in a cloud environment.
Yeah, because CloudTrail and CloudWatch wasn't giving us enough information without that raw network traffic. And now we're starting to see it. But that also creates a very interesting challenge as well, because if we think about collecting packets on-prem with appliances and stuff, how do you collect that effectively in the cloud? You're not deploying agent or appliances per se, right? I mean, how do you effectively get that packet data into something like an ExtraHop and correlate it with the data that's coming from the appliances, like on-prem, for example?
Yeah, absolutely. We talk about, you want to do the processing as close to the point that the data is generated as possible, right? As close as to the point of the actual sender or receiver of that traffic. Given the data tax of taking data out of the cloud, ideally you're not spanning back over a transit link into your data center. They like their data coming in, but cloud vendors don't typically, you're going to be charged for data coming out. And so we want to do all of that packet processing within the cloud itself. And so the beauty of ExtraHop, whether you want to do that packet processing within your security boundaries, so within your VPCs, for example, or you actually want to leverage ExtraHop's cloud service, where we do packet processing as a service, where you end up with a traffic mirroring target and you just feed us the packets and we do all of the processing. At the end of the day, it ends up being the same end result, the same insights, whether you're on-prem or in the cloud, because at the end of the day, a packet is a packet is a packet. That's the beauty of using them as a source of data.
Yeah, that's great. So let's get into it, right? Because I think we've talked about some of the challenges. Let's see how you solve it.
Yeah, absolutely. Real quick, just to kind of set the stage, I just want to talk about where NDR sits in terms of a security architecture. And specifically, when we talk about security architectures, I really like to focus on SIEM, EDR, and NDR, where SIEM is going to be any sort of log files. I mean, we're all familiar with SIEM. It's usually one of the first pieces of technology that gets put into a SOC. EDR focused on the endpoint, where you're looking at things like memory, you're looking at specific files that are running on the system. And the third leg of the stool is really going to be the network, where I don't know a single environment that has complete coverage with their SIEM. They have log files from every system. They have an endpoint on every system. And so the network kind of is the thing that ties all of those hosts together and gives you the 10,000 foot view across your entire organization. When I am talking to CISOs, I like to ask the question, how much of your environment do you actually think you understand? Take, for example, we tear it all down. How much of it can you rebuild tomorrow using just the documentation you have today? Hmm. And the answer is usually maybe 80%. I think that's an overestimate because working with the network, usually we find hundreds and hundreds of things that always end up with a, it wasn't supposed to do that. And so that's the beauty of the network.
Or I didn't know that was there.
Or I didn't know that was there. Or I didn't know that was still on, which is my favorite. When we talk about using NDR and cloud native NDR for the hybrid enterprise, going back to a packet is a packet is a packet. We do the processing of those packets wherever they might be, whether that's in a remote site, whether that's in pick your cloud vendor, whether that's in a main data center. And from those packets, we're extracting useful metadata about those packets. And when I talk about metadata, we're not talking in the traditional, NetFlow sense where you have sender, receiver, what port it's on, how many bits and bytes, but actually pulling into the application layer. So looking for one stateful analysis. So not just sender and receiver, but client and server, but also looking at what is the general behavior. So I like to use the example of a login failure. Pick your protocol, and most of them have the concept of a login failure, whether it's a database, whether it's a file share, whether it's HTTP, right? And so as we actually extract that concept of the login failure from each one of those protocols, you can start applying advanced machine learning against it, start doing anomaly detection, and find things like brute forcing, because we've extracted away from the individual implementations of what a login failure is, and now can use the higher order concept to trend general behavior in the environment.
So not only are you collecting the data, you're normalizing it in a way that you can use it across a bunch of different protocols, so you can see things in a very holistic way.
Exactly. And the beauty of the network itself, it doesn't matter if you're in the cloud, it doesn't matter if you're on-prem. Those protocols are standards for a reason. And so we can use that same type of analysis for all of those environments. So with that, let me share my screen. And hopefully you can see that okay.
Yep, see it fine.
Perfect. So from the second that you start sending us packets, we're going to be doing that analysis in real time. So it's not your traditional packet to disk and then doing forensics against those packets. You're not just writing Berkeley packet filters to parse through those packets. It's actually in real time doing that decapsulation, doing that decryption, and actually pulling out, one, what are the assets on your network? What roles do they serve? What type of asset is it? So asset classification, and then building all of those trends on top of those. So when you first log in as an analyst, you're going to be exposed to this page. And this just gives you a high level summary of what is happening on the network right now. So what sort of detections are we seeing? What sort of assets are we seeing? And we'll get in deeper into all of this, but just again, high level overview, what's happening right now? What do I need to prioritize on my network? Building a foundation of what's happening on the network, we actually have a network-centric view where I can see what are trends in terms of different indicators of compromise, different types of behaviors on the network, whether that's from a hygiene perspective, whether that's from just specific, again, indicators of compromise, but also what are the relationships in my network? And so we can see your database activity in particular. And then finally, understanding what is the interaction with my environments, with the outside world. And so we have a couple different views here. One, looking for large data uploads. And so this can be both cloud services. This can be, we actually see here S3, but also just external IP addresses. And you actually can see where we've marked with this red bar. If I click that, we've actually layered on threat intelligence. So both bring your own as well as threat intelligence provided by the extra threat research team, where we've actually marked a specific endpoint as being suspicious. And you can see we've pulled additional information, again, on that asset classification, role discovery, where we can actually call out why was this endpoint suspicious, and we'll get into more of that later.
So, Chris, I want to stop you here 1 second because you just showed two screens, but I want to break it down for people. You're monitoring north-south traffic, right? That's ingress and egress traffic, but also east-west traffic, right? And as I think about some of the early challenges in network detection and packet capture was because of the way you had to do it, people were only looking at north-south traffic. It was very hard for them to look at east-west traffic. What ExtraHop's done is taking not only north-south traffic, but also the east-west traffic and bringing it all together in one interface, which a lot of organizations have struggled with in the past.
I think one of the big challenges and why people focus so heavily on north-south early on was one that just processing wasn't there. We weren't able to process the amount of data that was being generated in the average enterprise environment. When you're looking at north-south, it's typically going to be a 10 gig link or less. I operate in environments that are processing petabits per second in terms of total packets. And part of the reason that we can do that is because, as I mentioned earlier, we're actually doing that processing up front. So you're extracting that metadata in real time and storing the packets as well. But when we're talking petabits per second, how much disk is that? You're going to have several racks worth of disk just to store any significant amount of PCAP, right, to do forensics against. And so it really lets us analyze both that east-west as well as north-south. I like to say as well, as you push into the east-west corridor, if we think of your typical three-tier network architecture, as you push into the distro layer, for example, you get north-south for free, because guess what? It has to cross that network boundary to get to north-south. So you get east-west plus north-south just by looking at east-west.
A great point.
Yeah. One final view, again, as we look at just, again, the general behavior of this environment, looking again at those various cloud services where we can actually break this down if I wanted, where we can see the specific endpoints that are being connected to by those individual endpoints. And this is everything from AWS, Azure, even I think ExtraHop is on there as well. But also things like looking for DNS over HTTP or DNS over SSL. We actually will call out those services as well. I know that's kind of an up-and-coming topic for a lot of security practitioners. So, and again, all of this, it doesn't matter whether that data is on-prem. It doesn't matter whether you have sensors distributed across remote sites, cloud environments, as well as on-prem. You have this aggregated view across that entire deployment so that you can see all of those individual processes, all of those individual assets working in tandem.
Right. Yeah.
Cool.
Bringing all that data together. Yeah. Lots of data.
Lots of data. And that's data is one of my passions, and this is the platform for it. So I talked a lot about just, again, getting a general view of what's happening in the environment, kind of building on that. So I mentioned doing that asset discovery, asset classification, asset identification. You can see here a breakdown of different types of assets and different types of entities that we actually have under observation. So not just by specific protocols, but we can actually see by specific roles. So picking out things like domain controllers, mobile devices, PCs. Another entity that we track as well is actually specific users. So if we go look at what users we're seeing on the network, and I can type in admin here, right? And we can actually see where administrative accounts have successfully authenticated and what devices those accounts have authenticated against.
Yeah, you want to talk about asset management as a problem, right? everybody has a struggle with asset management. I mean, you just gave them asset management. It's all right here. And not only just the physical assets, right? And you break them down by all these great breakdowns. You're also associating users and who's using those devices, which is a really powerful association.
Absolutely. And I think, again, it's important to emphasize this is all done totally passively. This is all done using exclusively passively gathered network traffic. We're not doing any sort of synthetic network scans. While we can integrate with EDR vendors, for example, we don't need it. Just because we parse all of those authentication protocols, because we're constantly monitoring for changes in IP address, we can actually track where an asset is in the network, what its current IP address is, and who is using that asset.
Got it.
So we'll go and drill down into one of the specific behaviors, but when I'm first entering a network, often as an incident responder, and I'm just trying to build an understanding of that network, one of the first things that I like to do is actually go and look at one of those activity maps that we looked at in kind of the first screen, where it gives me an understanding of what are the relationships in the network, what are the clusters in the network that I'm seeing. And you can see we've overlaid some of our detection here. But one of the things that I like to do as well is this actually supports doing time-based comparisons. So if I have a specific time period that I'm interested in, I'm looking for what has changed against that time period, I can actually, we're looking at about 6 hours. If I cut that in half and do 3 hours and 3 hours, I can compare the previous 3 hours versus the current 3 hours. And you can actually see green is new activity, new connections, new assets that we have observed, and red is previous behaviors that are not currently occurring. And so this lets me quickly identify what new assets are on the network. It lets me identify, if we actually scroll over here, we can see, decided to refresh. We can see green new traffic. And if I actually hover over this, we, in the last 3 hours, have started seeing 6 hosts using the Stratum protocol, doing crypto mining, right? And this is, again, we were called out to this already because we have several detections in this part of the environment, but it gives perspective around where am I and when do specific events happen on the network.
The other thing this map shows is you see your clusters. You've got one like in the middle that I don't think it's connected to anything else. That must be a kind of an isolated network somewhere.
Yep, yeah. Absolutely. You can actually see that we've identified this as several remote devices. And that's where, again, when you have disparate sensors spread across hybrid environments, this is a fairly common pattern where you'll see specific clusters of devices because they're serving specific business purposes in specific locations. And this lets you quickly drill out and drill back into all of those different environments.
That's great.
Yeah. And one final thing on that, you can actually see I started at the top level where I wanted to look at everything. You don't have to start at the top level. As an analyst, you have one area of focus typically, and you can have one of these views for just the area that you're responsible for, so that you have a quick understanding and a quick view. Log in at 8 a.m., take a view, see if anything's changed, anything that you need to go look at. Jumping back, we have some idea of what's happening on the network. We have a general of some of the clusters that are in the network. But I want to show just some of that metadata and what that metadata looks like, because it is the foundation of machine learning, right? You don't have machine learning without some form of cleaned data. And that's really one of the superpowers of ExtraHop, is quickly extracting all of those features from which we can do advanced machine learning. So if I go look at database servers, for example, real quick, we get a view of what are the actual databases that fall into this database server category. What is their general behavior? We can see some CIFS, we can see some SSH traffic. That might be something that we want to call out and note down for further research. But really, we want to go look at specifically the database servers acting as database servers, right? And so when I talk about metadata, when we talk about features of machine learning, a feature can be how many requests or how many total bytes or what are the types of methods being used. And so when we look at things like the top methods here, we can actually see, again, all extracted in real time, all no configuration necessary. We can see what methods are in use. We can see what databases are actually being queried against. We can also see trends over time, right? And so we can see spikes in the total number of responses, total number of errors. And this is where, when I want to go look at specific errors, with a single click, or I guess 2 clicks if we want to be pedantic.
Get technical.
We now have trending over time of all of the individual errors. Again, no agents. We don't have anything installed on those databases. I don't care if this is an instance base or a database as a service technology, right? It's all backed by the same database technologies. And so I can now go and see we do have some too many connection errors, potentially something that has performance impacts, especially under something like a denial of service. I'm more concerned about all of the access denied events, right? And because we can see for admin, SA, tour. And so my next question will be, well, let me actually see the individual transactions associated with that specific error. And so I can click on the little magnifying glass, and now I actually have every single transaction that actually meets that error condition. So this is all database transactions with this error, right? And I can see it looks like it's all from this specific client. It's all towards the specific server. So there's a couple of steps we can go from here. We can actually add these as filters. I say I'm exclusively now interested in the interaction between these two endpoints. And you know what? I can see we had those 27 errors, but I just want to see all of the transactions associated with those two endpoints. And by clearing out that, go ahead.
Yeah, so you're doing an interesting pivot, right? You said, look, this looks malicious. Is there any other malicious communication between these two hosts? Take the database error filter off, just show me everything between those two hosts, right?
Exactly. And that's, so when we were seeing all those authentication failures, we can actually still see those on the left-hand side here. Mm-hmm. But now we also see select method, set method, show method. And so we can actually pivot. We were very, very narrowly focused. We found something of interest. We expanded our net and pulled back a little bit to look at more broad behavior just between two specific hosts. And then we can narrow our focus again by hitting the select statement. And now we're looking at just specifically queries using the select method. So it's successfully authenticated. And I think a reasonable question would be, what user successfully authenticated against? Someone actually popped one specific user. And that's called out here, right? So it was actually the EH user. And then we can go and look at the specific statements from within there. And if I want a nicer view of this, I don't want just each individual transaction, but give me a count of all of those transactions. Boom, group by the specific statements. And now we expand our scope. We narrowed our scope again back onto this specific select method. And then we can narrow it even further, where now I'm going to add that. I'm looking for just a select star from account. And the final step would be, I probably want those packets. I want to know what is the blast radius for what they had access to. And
how many records did they actually get, right?
Exactly. And so we see these little bullseyes here. If I click one of those bullseyes, those are just the packets associated with that one transaction. So in one click, I didn't have to go write my Berkeley packet filters. I didn't have to go parse through payload. We had already done the payload processing, and we knew the indicator of compromise. We knew the thing that we were looking for. And so now we've actually gone and grabbed just those packets. And just to give you an idea, we found 180 meg. If I clear out these filters, it's not even going to bother buffering all the packets it has available to it at over almost 16 gig. So we're very, very quickly able to narrow down to just one specific set of packets. One other thing that I'll call out here as well, the download session keys. So I've mentioned that we do decryption, and I think that people don't understand necessarily the importance of encryption because they're not used to being able to, on the fly, process packets. Lots of tools, Wireshark included, you can have the private key and do the decryption once you already have the packet capture, right? But when you're extracting on the fly and doing machine learning against those application layer behaviors, you want to have access to that decrypted traffic in real time. And so XROP supports, doesn't matter again if it's in a containerized environment, if you're using EKS or ECS, doesn't matter if you're on-prem, we can decrypt public-private key cryptography, but we can also decrypt PFS-based cryptography as well. So if you're using the Diffie-Hellman key exchange, TLS 1.3, we can actually still do decryption against those protocols, still totally passively. I work with a customer who uses the PFS decryption not to decrypt their own application traffic, to actually decrypt APIs that they call from other third parties, because the beauty of PFS is that you can actually do client-side decryption. We all wish that logging was perfect. We wish that every application logged every single thing that you wanted. You don't always get that. And being able to decrypt client-side APIs on the fly passively lets us navigate around having to work with developers to add specific logging for custom-built applications. Lets us work around log files generated from third-party vendors that maybe don't have all of the pieces of information that your security team needs.
Yeah. Plus, if you're a really good attacker, you're trying to encrypt your traffic to hide yourself, you have to see the decrypted packets, especially when it comes to things like ransomware and some of these other attacks, right? Without the decrypted traffic, you wouldn't be able to see what's actually going on in those traffic streams.
Exactly right. So I show all of that to pull back and say, forensically walking through all of the data, it's something that we honestly hope we don't have to do. We have to do it every day. But you need that data, again, to apply machine learning against it. And when we look at the different types of machine learning that XROP uses, I divide it into three different categories. One is understanding the network, perceiving the assets and entities on the network. And when I talk about that, I talk about things like device clustering, asset clustering. So when we look at what assets behave the same way, right, there's not necessarily a right or wrong answer, but when you apply, you often see clusters of specific user devices. Mobile devices all operate very similarly. You see developer workstations operate very differently from HR workstations. And so we can actually go and start doing anomaly detection against those clusters where you have a set of devices that should all behave the same, and now one of them isn't behaving like its peers, right? And so we can actually say, given a period of time, we started seeing a device use a new protocol. It doesn't matter what the protocol is, and this is the beauty of obfuscation, where the entire point is looking for changes in behavior. It doesn't matter that it's SSH or RDP or HTTP, or we're just looking for that new behavior, right?
Right. And it doesn't matter where the device is, cloud, on-prem, whatever, you're bringing all that data together.
Yep, exactly. We also can look for specific indicators of compromise. Of course, you have your rules-based detections on one side, but we can actually quickly investigate and walk through the chain of those indicators of compromise. So we pull out, so the anomaly detection that we talked about, the clustering that we talked about, we're pulling out specific indicators of compromise, but then using machine learning as well, identifying important things to surface to the analyst to make that investigation time shorter. So what related records do we think are critical to investigating this detection? What other detections have we observed that we think are related to this specific event? And so we can actually see we have a specific Drupal vulnerability. And the thing that I often look for here is looking for role transition, where you have something going from offender to victim or victim to offender. And in this case, we actually see victim, and then from this time point going forward, it's starting to act as offender, which means this Drupal vulnerability was successful. They gained a foothold on that host and are now able to take additional lateral movement within the environment based off of that new foothold.
Yeah, Chris, this is awesome. I mean, thinking about what you provide to the analysts and all the steps just makes it so much easier to dig in and find this. Unfortunately, we're running out of time, but this was a great overview of what ExtraHop can do to really provide visibility and detection in these very hybrid environments. Thank you.
Absolutely. Thank you.
After this session, you will be redirected to the Knowledge Center. Please feel free to download any of the assets available from ExtraHop. Also, if anyone wants to ask questions, please join our Discord server and get connected directly with ExtraHop. You can also visit securityweekly.com/ExtraHop to learn more. Thank you for joining us.